software. So this is PowerShape, and you can see here I've got the basic design, the basic assembly in place. Let me just turn the assembly off and zoom in on the point cloud. Okay, so this is actually a cloud of points. And if I zoom in, you can just about make out the lines that the laser captured. And like I say, you tend to go over this type of data, the same area multiple times. So I've got to process the point cloud data, and I'm going to fit a mesh of triangles to the point cloud. So we basically fill the gaps between the points with triangle data, and I can enter some parameters to do with the step over and the hole fill, which affect the quality of the resulting triangle model. Okay, so that's the triangle model that PowerShape has given me. Now, I could do some work on this triangle model, but in fact what I'm going to do first of all is to divide this into the two major areas. So I need to split the hub from the blade, and I can do that using this limiting tool. Okay, so I'm going to zoom in on this dividing area and draw a polygon, just sketching a polygon which will divide the two areas. Okay, so I'm separating the blade from the hub. As soon as the polygon's closed, the operation's complete, and it looks as if nothing has happened. And if I just change the material of the blade, you'll see now that we have two completely separate triangle entities. Okay, so if we start working on the blade, now obviously the quality of this data is not perfect. You can see some of the lines. This is to do with when we capture points from the same area, you end up getting slightly different Z heights. So every time the laser passes over the same area, you get a slightly different reading, and this can affect the resulting triangle model. Now I have a set of tools in PowerShape that would let me clean this data up. I could fill the holes, I could smooth the triangles to give me a perfect blade. And in this case, I've no need to do that because I can simply select triangle data and ask PowerShape to fit the smoothest possible surface it can through that data. Okay? And this is the resulting surface. And we can get a readout showing us the fit of the surface to the triangles if we wish to. Okay, so that is currently a surface. Now the first thing I'll do with that surface is convert it into a parasolid. So this is now, as Vineet mentioned, this is an infinitely thin parasolid model. So the first thing I'll do with that is to give it a thickness, and the thickness of my blade is 2 millimeters. Okay, so now when I zoom in on this edge, you can see we have thickness. Okay, let me just hide the blade, or hide the smooth surface for one moment, and again look at the blade profile. So the next thing we have to do is to capture the outer edge shape of the blade that we're constructing. So I can now use PowerShape's geometry construction tools, so we can construct lines, arcs and curves, and I can simply touch on the edge of the triangle data, and in this case construct curves. And you'll notice that PowerShape has a very powerful, intelligent cursor. So the cursor's continually giving me feedback about tangency and point information. Okay, and I can confirm the radii to construct good quality geometry around the edge of the blade. Okay, now I have the finished profile stored on a level, so let me turn that on. I'm going to use that profile to construct a surface, which is just a simple extrusion. Let me get my smooth solid back, and then I can use that extrusion to limit the parasolid. The triangles for the blade are no longer needed, so they can be removed. Now currently you can see that this shape has a sharp edge. I want that to have a nice smooth profile, so I can use a rib fillet construction where we pick the edge, and PowerShape will create the smoothest and the largest radius it can all the way around the blade geometry, removing that sharp edge very simply. So the blade is finished, so now we can turn our attention to the hub. And again, I'll start by capturing a profile through the centre of the hub, and I can do this by taking an oblique curve through the triangle data. Now, if I draw that oblique curve on its own, you'll see again, because we haven't done any smoothing operations on the triangle data, the quality of the curve that I get is far from perfect. But again, I can use PowerShape's geometry construction tools to use the oblique as a kind of template and reconstruct the profile exactly as I want it. Again, confirming all of the values as we go. If I touch tangent, tangent, confirm the radius, and that gives us a nice, smooth, good quality geometry to start with. Again, I've already got that curve constructed, so let me get all of the data back. And again, we'll use that profile to construct, in this case, a solid of revolution. And again, the triangles are now no longer needed, so I can delete them. So now I have my hub and I have my blade, but at the moment they're two separate solids. So let me make the hub active, select the blade, and we can join those together with a simple addition operation. And you can see now we have a single solid. Now every operation I perform on this solid is captured in the history tree, and at any time I can either modify the history tree or use the history tree to modify the shape. So here I've selected the single instance of the blade, and I'm going to create a pattern of those instances, and in this case we want 3 elements, so 3 blades centred around the hub. Okay, and we make a pattern of blades, and once again we have a sharp edge, and I wish to remove that sharp edge and give it a nice smooth edge, so we can do a solid filleting operation, enter the fillet radius, and I can in this case select all 4 fillet curve centre lines in one go and create a smooth blend. Flipping this blade over, at the moment the hub has a solid shape. Now again, I could construct the wireframe geometry in the short amount of time I have for this demonstration. I've already got that created. So this is lines, arcs and curves in the correct position, and I'll use those to make a cut into my solid boss. I can enter the depth of the cut, and I can also give this a draft angle and apply the operation, and we make all 4 cuts in one go. Again, I have sharp corners that need to be removed, so I'll perform a fillet operation. And we have some nice tools with solid filleting. So for instance here, I can pick a single face of the solid, and you'll notice that multiple edges are selected in one go. So in this case, we create 16 fillets with one single mouse click. Also, I can fillet all the edges of a particular face. So if I pick this face on the top, again we create 5 fillets in one go. Again, I can select multiple faces, so here 4 faces, and in 3 filleting operations we've created over 30 fillets. Okay, so my blade shape is now complete. If I draw the assembly, I still have a little bit of work to do to complete the assembly of the blade itself. So let me start just by drawing the motor and the fan. Okay, so that the shaft of the motor passes straight through the centre of the fan, and I need to add some manufacturing information. I need to add the hole that the motor shaft will fit into. Okay, and we're going to do this with assembly modelling. So I'm going to drop into assembly mode. First of all, pick my solid and convert that into an assembly component. Now this is an assembly. I can now use power features to automatically create the manufacturing information. So without doing anything more, I can ask PowerShape to generate the power features. PowerShape analyses all of the geometry that we have in the part, and if I now draw the rest of the assembly, I'll then show you the blade on its own. Without me having to do any work at all, we have all of this hole and recess information stored as power features. You can see it's a very simple operation to add those onto the main blade. Now also, we can make changes to this. So if I select the main blade geometry, I could say I actually wish to modify that geometry. This will expose the history tree of the solid. So I can work down the history tree, I can find the operation that I wish to change, so in this case the number of instances of the blade, and I could choose to change that from 3 to maybe 4 blades, and the whole history tree will very rapidly update, and you can see now we've completely changed that blade from that fan from 3 blades to 4 blades. Okay, so if I just drop this into advanced mode, you can see there is our finished assembly, and we've used every entity that PowerShape supports to create that